This evening, it's a great pleasure to introduce Andrew Gulson. We've been discussing this for a number of months to get this organised and get dates together. So I'm really grateful that you've given up your time to do this. This presentation is on behalf of the College of General Dentistry, and Andrew is going to look at the updated guidance. And Andrew Gulson is a specialist radiation protection scientist, and you've also worked for what was formerly Public Health England in that role, and you were heavily involved in the previous guidance and the current one.
Yep, all the guidance.
All the guidance, that's it. So you're absolutely the right person to speak to about the guidance. Okay, so Andrew, thank you so very much. I'll say over to you.
It's a pleasure. Thanks, Robert. Okay, good evening, everybody. I would normally say it's really nice to meet you all. I'm still going to say that, even though I can't see who's there and how many of you there are, but I'm hoping it's a good number. I'm hoping you'll all find this useful and interesting, and I look forward to answering any questions that you have at the end of the presentation. The online way we're doing this makes it a bit harder to do the natural thing and just raise your hand and shout out a question. So here we go then. So the dental guidance notes, this is the second edition that I was involved in putting together. Essentially, the dental guidance notes, and hopefully you're all aware of them, are advice for dental practices on how to comply with the UK radiation protection legislation, which I'll come on to shortly. There's two bits, one addressing staff, so occupational health and safety at work, and another set of legislation affecting patients, protecting patients. So the dental guidance notes are actually aimed at the group of dentists working outside of the hospital sector. Within the NHS and private hospital sector, there's a much larger document, even bigger document than the dental guidance notes, addressing all uses of ionizing radiation within the hospital sector. We've actually got ours out and published before the hospital sector were able to update theirs, which is good news for us. So the guidance that appeared in October 2020 was the second edition. The first edition was this nice light blue publication, which appeared in June 2001. And yeah, that was the only bit of guidance I've not had anything to do with. So I should just correct the earlier impression. So the second edition was published a couple of years ago nearly. It's on the CGDent website at the link below. So, well, why did we do it? Why do we feel the need to go through 2 years of hard work to put this all together? Well, first of all, the legislation that was in place when the first edition was published was replaced in 2018. So the old ionizing radiations regulations 1999 were replaced by the IRR 17 version, and also the IRMA legislation, which first came out in the year 2000, was replaced by the ionizing radiations brackets medical exposure regs 2017, IRMA 17. And it's IRR 17 at the top, which regulates the occupational exposure to ionizing radiation in all sectors, not just dentistry, not just the health sector, but industry, research, teaching, you name it. All radiation at work is subject to IRR 17. The IRMA legislation, that is the legislation in the UK that aims to protect people undergoing medical exposures to ionizing radiation. So that's X-rays, nuclear medicine procedures, radiotherapy, diagnostic X-rays, the whole range of medical exposures. And dentistry is subject to both of these pieces of legislation. Also, and by no means secondary in importance, since 2001, when the first set of guidance notes came out, virtually everything changed. So we had developments in imaging technology, the old wet film based imaging, where people put the films through either dark rooms or desktop processors to develop an image. Most of that's now gone. There are still some practices using film-based imaging, but I'm sure most of you now are using either phosphor plates or digital sensors, both of which we term to be digital because the image is reported electronically on a computer screen. Also, we had entirely new X-ray modalities arrive. Cone beam CT was the first of those, very different to anything dentists have used before. In fact, to this day, any dentist who graduates in the UK won't be qualified to use dental cone beam CT or to report on the images. That's still something that needs to feed through the system. I'll come on to that later on. And also handheld dental X-ray equipment, where most intraoral X-ray sets are bolted to walls, and the dentist stands a good 2 meters plus away with a curly cable, well away from the source of scattered X-rays and the radiation hazard. Handheld dental X-ray equipment, you hold that thing in your hands. So all these things were radically different and needed thinking through as to what the safety implications were, needed thinking through in terms of how people using these would, well, whether they could at all comply with the regulations in the first place. And if they could, then how do we advise people to do so? So dental cone beam CT, a lot of them look very much like panoramic X-ray sets. I know some of you will be very familiar with some of the things I'm taking some time to explain. So I hope you'll bear with me for the benefit of those who don't use this equipment. So dental cone beam CT equipment, it is a form of 3D imaging. Some modern panoramic X-ray sets, all they require is a software upgrade to switch from being panoramics to dental cone beam CT. The image that's half hidden in the middle is one of the earlier versions where the patient actually lies down and gets fed into this tumble dryer type affair, which is very much more like the conventional medical CT you'll see in a hospital. Now, one reason, or what's more than one reason, the main reason why we were interested in these first of all was that the dose to the patient from a dental cone beam CT exposure is a few times to a few tens of times, and in some cases even a few hundred times the dose from a single panoramic exposure. The imaging software requires several basis images taken at intervals of a few degrees as the X-ray tube head and detector rotate around the patient's head, and then the software very cleverly reconstructs a fully manipulable three-dimensional image of the patient with a very high degree of dimensional accuracy. So it needs a lot of radiation to do that. So the patient doses are higher. That puts a lot of emphasis on making sure that the correct patients are referred for the correct examination for to answer the correct clinical question. So there's a referral policy issue there, but also there are issues in terms of what levels of shielding are required for dental practices where these items were starting to be installed. The shielding that would be required, or perhaps not required at all, for an intraoral or panoramic installation needed rethinking in terms of dental cone beam CT. Whatever dose you give the patient, a small percentage of that will be scattered to the boundaries of the room, and if the dose from a cone beam CT is that much higher, then obviously it puts more importance on making sure the rooms are adequately shielded. So those were our two main concerns. And then of course we needed to make sure there was some understanding of the training that was required by people operating, reporting on the images and referring patients for these examinations. All these people needed to have their training needs sorted out and documented, which we've managed to do. So that's dental cone beam CT. Handheld, there's a huge variety of different models available now on the market. This is one of the leading brands. Here's another one, and yet another one. Now these are built to quite a wide variety of standards. Some are very good and some are not so good. And the model that really alerted us to there being a potential problem was this one. This is the Jiangxi Dental Falcon, bought online from China, direct. It cost £200 postage and packing, arrived within a week of us placing the order, and we took it out the box, and it just didn't feel very much like a quality product. We did some extensive testing on this in our laboratories at Leeds, excuse me, and we found out that the shielding afforded to the operator was less than the shielding afforded to the patient by virtue of the 1.5 millimeters of aluminium in the tube head just here. So every time the operator pressed the exposure button, they got a higher dose than their patient. And yeah, that was the main concern, really. A dentist who used this for a high radiographic workload, week in, week out, could possibly exceed the statutory dose limit, which was unheard of in dental radiation protection. Dentistry is considered one of the lowest risk radiological work activities you can undertake, but it's only that way because of the generally high standard of X-ray equipment that is available to the profession, and also the plethora of guidance that has been there since the year dot in terms of how to use it safely. Okay, so those are the two drivers in terms of equipment that led us to want to update the dental guidance notes. So who did we get on board to help us with this process? Well, the regulators, the IRR 17 regulators in the UK with the Health and Safety Executive, HSE, and their Northern Ireland equivalent, but also the regulators for England and the devolved nations for IRMA, so the Care Quality Commission and the RQIA for Ireland, the Health Inspectorate for Wales and Health Inspectorate for Scotland. Sorry, I can't remember what RQIA stands for. There's too many acronyms in this business. I'm sure you'll sympathise. So the regulators were there. We got as many of the other stakeholders as we could possibly think of together as well. The British Dental Association, General Dental Council, the FGDP, who's now of course become CG Dent, and the British Society of Dentomaxillofacial Radiography. And if I can say that, then I know the rest of the lecture is going to go pretty well, so I can relax now. And some consultants who had helped us in the previous times putting together the dental guidance notes first version, and the interim guidance on cone beam CT and handhelds that got subsumed into dental guidance notes version 2. So we have, for instance, Jackie Brown, Professor Jackie Brown, Professor Keith Horner, Nick Drage from Cardiff, and several others, and they gave up their time and put a great deal of effort into helping us get getting the clinical credentials into the dental guidance notes. But also, it was important to get actual high street dentists and dental nurses and hygienists involved too. So we also made efforts to do that. And then we found we had a room full, and we could only squeeze in a couple of other RPA type organizations, such as changed the name now, but DBG, and a few other individuals who are notable within the UK as providing RPA services, and also IPEM representing the hospital sector, and SRP, the Society for Radiological Protection. Okay, so that's just about everybody we could possibly think of. So as well as the need to address the technical issues that arose through there being new equipment, there was also the legislation, but it was also an opportunity to try and reformat the guidance notes in something a bit more palatable, perhaps. If anyone has any comments at the end of this on whether we were successful in that, I'll be very glad to hear them. It's a year since publication, so I am interested in gathering some feedback from people. But we were aiming for a lot more logical ordering of topics than perhaps the 2001 version accomplished. From doing the handheld guidance and the cone beam CT guidance, I felt that in putting in checklists to enable people to just tick off things as they went through preparing to use this equipment, if perhaps they're setting up a dental practice for the first time, those would all be useful, and to make it as plain English as possible. And thanks to CG Dent, it's available free of charge to anyone on the CG Dent website. Oh yes, I did want to mention that all the section headings and the contents are fully hyperlinked, so you can navigate around the document fairly successfully, fairly easily. So this is just an example of one of the summary pages where, if you're setting up setting up a dental practice for the first time, you can go through in chronological order what you need to do. For instance, register with the Health and Safety Executive, appoint an RPA, consult and appoint a medical physics expert, etc., etc. Okay. And yeah, sort of a tabular presentation of the material where it was thought to be useful. I thought that was quite important too. So just a bit about some of the contents before I get on to the actual meat of what the regulations say, sorry, what the guidance actually says. So given that it's ordered roughly chronologically in the order in which you would have to address each of the requirements of the regulations, IRR 17 naturally comes first because you need to notify HSC before you can do anything else. Then you've got the administrative aspects of IRMA, or your employer's procedures you need to get drafted and put into place. When you're actually working with X-ray equipment, you need to know how to practically achieve the optimization of patient doses. And of course, quality assurance, inescapable in any medical exposure situation. So that's the order in which the guidance was laid out. Just briefly, I want to mention all the highly useful stuff, I hope, that people have come to agree with. We put that in the appendices so it wouldn't clutter up the main body of the guidance itself, but there's all sorts of things in there. Perhaps if you're not aware of this, go and have a look and just see what there is. For instance, the right answers when you're filling in an HSC registration. The HSC have told us that lots of dentists have registered for incorrect things, such as the administration of radioactive materials to patients for research or veterinary purposes. You know, you don't use radioactive materials. You don't need a consent for industrial radiography or to operate a linear accelerator. Lots of dentists, we're told, have incorrectly got themselves registrations for the wrong thing, or even consents for much higher risk activities, which they don't actually do. There's 14 IRMA procedures which all dentists have to have set down in writing. So we thought it would be useful to actually write those for you. They're template form, so you can fill in your name, address details, and delete bits which might not apply, such as if you don't use cone beam CT, you can delete the relevant sections from your referral criteria of the procedure. Okay, so yes, also I've just mentioned this, dental cone beam CT, the full syllabus regarding what you would need to do whether you're operating, referring patients, or reporting on cone beam CT images. That's all in the appendices too. So I can't think of anything that we forgot to include, to be honest. So in terms of what the guidance actually says, I'm going to go through that now. I'm going to pick out what I feel are the main issues from both IRMA and IRR 17. Of course, if there's something you've seen and you want that explaining at the end of the talk, then yeah, by all means suggest it, and we'll cover that later on. So, shielding requirements, designation of controlled areas, how far they extend and how long they last. These are all new things, revised things, sorry. Revised recommendations on lights and warning signals for X-ray equipment, and also for rooms now. And recommended approach to personal monitoring has altered slightly since GN's number 2. And this is new to dentistry, the requirement under IRR 17 for radiation measurements around controlled areas. Okay, so some of these things I'll go through now. So in terms of shielding of X-ray facilities, since 2001, intraoral panoramic caphometric doses per exposure to patients are lower, in some cases substantially lower, particularly for intraoral. Doses have fallen by about the factor of 5. So that means that the amount of radiation scattered towards the boundaries of a dental X-ray room are that much lower too, which takes some pressure off the shielding required. We also know that around 6% of the intraoral beam is transmitted through the patient in the worst case situation, and that amount of unattenuated beam actually strikes the wall. In the absence of having that number, we were either assuming it was 100% or 0. I mean, it wasn't 0. So now we have a good number that's workable for us to actually calculate doses and therefore calculate the shielding required. And we've got basically better science underlying the whole process of calculating what shielding is required, largely thanks to one of my colleagues, John Holroyd, who works in the medical exposures group of UK Health Security Agency, who put this guidance together in the Journal of Radiological Protection. So what's the outcome of this? Well, if you had a partition wall, the dental guidance notes would have said, regardless of what that surgery contains in terms of an X-ray set, a partition wall would always require shielding. We would no longer advise that. It would depend upon all the relevant factors. It would depend upon how far away from the wall the X-ray set was, how many shots would go in that direction towards that wall, how often the area on the other side of the wall was occupied, etc., etc. All these factors would influence the dose to a person stood on that far side of the wall, and therefore can be taken into account now when we're providing advice to dental practices on what shielding is required. It's not a yes-no situation anymore. Some surprises possibly are that ground floor windows might not need shielding, even if they're in the intraoral X-ray beam or close to the X-ray set. And again, that's an issue of accessibility of the area outside that window. If it's not a very routinely occupied area, as most ground floor windows lead into car parks or enclosed courtyards, there's no requirement for any shielding, and that's fully consistent with the radiation protection legislation. Doors are pretty transparent objects in terms of X-rays. So if areas outside doors are routinely occupied, there's a good chance those doors will need shielding, particularly if they're on the receiving end of an intraoral X-ray beam or on a dental cone beam CT, entrance to a dental cone beam CT room. Okay, but the watchword here is you you are required by the regulations to always seek advice from your RPA, your radiation protection advisor, whenever you're considering installing new X-ray equipment. They will go, the RPA will go through this process for you and provide a report giving you that advice, okay? And it's not appropriate for the installer to give that advice to you. They could assist you with putting together some of the materials the RPA would need in order to answer the question for you, but only RPAs are entitled to advise you on radiation protection questions like this, okay? So controlled areas, dentists know all about controlled areas. You all have them if you have X-ray equipment. Just to refresh though on what IRR 17 says a controlled area actually is. So it's any area, not necessarily in a dental practice. It could be in a nuclear power station, it could be in a hospital, it could be all sorts of places where radiation is used. But a controlled area in any of these places is somewhere where a risk assessment has concluded that people in the area need to follow special procedures, to avoid getting significant exposures, whether that's through routine day-to-day work or in the course of accident situations. Or, so it's not just one thing, it's not just special procedures. Someone working in an area is likely to receive an effective dose, it's a whole body dose greater than 6 millisieverts in a year, calendar year, okay? The second one, the 6 millisieverts a year, is more applicable to an area where there's a low level of constant radiation exposure and people work there most of the working year. So this is something you'll find more in the nuclear industry than in a dental practice, where radiation exposure levels are low and infrequent and, well, they're transitory, okay? However, in a dental practice, people do need to avoid doing certain things. You can still get a big dose with a dental X-ray set if you do the wrong thing all the time. So special procedures are required to keep your doses low. The regulations therefore tell you you have to designate a controlled area. But what they don't tell you then is what shape that will be and how long it should last for. So that's part of the risk assessment process to answer those questions. And again, your RPA is going to help you through that decision-making process. Just to mention regarding controlled areas, once you've decided you have a controlled area, there's lots of other stuff you have to do, such as draft some local rules, appoint a radiation protection supervisor, an RPS, achieve some form of physical demarcation of the limits of that controlled area. These are all straight out of the regulations. Restrict access to staff. Doesn't mean no staff can ever go in. It just means those that do go in have to be following these special procedures, okay, which will be in the local rules. And you also have to provide some form of dose assessment for anyone who goes into a controlled area. This has always been in the regulations, but the dental GMs 2001 managed to avoid doing anything about it. We didn't get that. We didn't get that option with the HSC involved in the working party. So now, where you have a controlled area in a dental practice, you have to have some form of area monitoring, measuring the radiation levels in and around the controlled area. Okay, I'll come on to that again later. So controlled areas, how far do they extend? Well, in the 2001 version of the guidance notes, there was this 1.5 meters plus the main beam approach, which had its advantages, but I don't think it was particularly well understood that this shape changed every time the X-ray set was moved to take a new exposure. So for instance, the 1.5 radius away from the X-ray tube and patient is the circular bit. What's happening here is that the emergent X-ray beam, the 6% of the beam that gets through the patient, actually persists and shines on the boundaries of the room. So this would be part of the controlled area too. And it would depend where this was pointing as to where this bit here arose, okay? I'm not sure that dentists particularly understood that, or some dental practice staff. I think there's a a suspicion that this 1.5 meters was the controlled area all the way around. It wasn't. The hazard persists post-patient in the X-ray beam. So for that and other reasons, the Dental Guidance Notes 2020 took the view that perhaps the neatest option was to go for the whole room as the controlled area. Okay, there's not much extra that you've got to do because of that. The operator can still stand inside the room if they wish. It doesn't matter whether it's a whole room controlled area or the other version shown here. Okay, but this approach, the whole room being the controlled area, does allow the physical boundaries of the controlled area to be physically demarcated, which is what the regulations actually require. So how long does the controlled area actually last for? Is it permanent, or is it a fraction of a second or a few seconds, depending upon the duration of the exposure, or is it something else? Well, in 2001, the controlled area was deemed to only exist whilst X-rays are being generated. Dental GN's second edition says now, whenever X-ray equipment is in a state of readiness to emit X-rays, the controlled area should be considered to be in force then, to exist then. And that's a little more sensible, because the risk isn't just when the X-rays are being emitted. There is a risk of an exposure when the X-ray set is turned on, and all it takes is someone pressing the button to fire the X-rays. So someone might go into the room at that time and that not be noticed by the operator, for instance. I'm just suggesting a scenario. So there would be a special procedure required just to make sure that there was no one near the X-ray set, even though X-rays weren't then being generated. And that sort of suggests the controlled area isn't just when the X-rays are being generated. You're still having to take precautions before and after to make sure that people are properly protected. So that's why now we recommend the controlled area should be considered to be whenever the equipment is ready to emit X-rays. It just needs a push on the button for the X-rays to be fired. For an intraoral X-ray set, that's whenever the power switched on in most cases. For panoramic and KEF and cone beam CT, it's a bit more complicated. You've got to put the equipment into a ready state, the software as well. You've got to put the patient in position and press the ready button on the equipment usually, which then enables the exposure button. So once you've readied the exposure button, that should be the point at which the controlled area is considered to exist at that stage. Okay, so that's the approach recommended now. So safety warning features. All X-ray sets have power on lights and X-rays on lights, but they can't all be seen from the operator's position, and we did consider whether that was a problem or not, and decided it probably wasn't. As long as there is some indication of the power to the X-ray set being visible from the operator's position, it doesn't have to be a light, it could be a illuminated computer screen or some other indication that the system's operational. That should be good enough. If you can't see the X-rays on light, which lasts 0.08 of a second perhaps, does that really matter? Virtually every X-ray set has an audible warning. If that can be heard from the operator's position, that's good enough. Okay, so that's the approach taken in the current new dental guidance notes. Rooms, yes. Now, IRR 17 says that warning signs or lights or some other means have to be provided at every point of access to a controlled area. That's just not negotiable. We tried negotiating it and didn't manage it. The HSC told us that we had to, sorry, too early then, we had to recommend some means of indicating the controlled area. It wasn't permissible just to rely on the operator to restrict access. Warning signs of some kind had to be recommended. So the image here is just showing a variety of control panels. They all have lights. They all show that the X-ray set is switched on. So as long as the operator has sight of that or a computer screen showing similar information, we're happy with that, okay? They don't have to see the X-rays on light. As I say, they can just hear the warning. If they can do that, that's all fine. So rooms, entrances to controlled areas need to display a sign looking like this now, okay? Even if the operator is standing by the only door to the surgery, there should be a sign like this displayed while the control area exists. So the counterpoint of that is when the control area doesn't exist, the X-ray set is switched off, although the equipment's not in use, it hasn't been set up for an exposure. That sign then needs to be covered up or removed. This is what we've now said in the guidance. Yeah, this is new to dentists, okay? So if anyone wants to discuss this later, that's fine. But it's a requirement of IRR 17. It was a requirement of IRR 99. We've had to recommend it this time. So surgeries that have a warning light that comes on when the X-ray set is switched on, perhaps a little easier if you have a sign that says something like this that makes it clear the controlled area only exists when the light is on. When you switch off your X-ray set, the light goes out. It's clear that the controlled area doesn't then exist. Okay. Right. So personal dosimetry in controlled areas. So one advantage, if you like, of the controlled area only being considered to exist whilst the X-rays were being generated was that there was no point at which people were actually entering the controlled area. So as soon as the X-rays had finished, the controlled area was considered to disappear. With the new approach, it does mean that staff are entering a controlled area, either just before exposure to set up the patient and place the imaging receptor, or just after to take the image receptor array again, but they're in there. Okay, so their doses have to be assessed. Again, this comes straight from the regulations by personal dosimetry, other suitable measurements. So other suitable measurements suggests that we cannot get around it by just doing a calculated dose. There has to be some actual measurement process. So what the GNs recommend is that personal dosimetry is issued to all people who enter the controlled area for 6 months, and then the RPA is able to review the data from that and decide on the need for further dosimetry. And in 90% of cases, I can tell you the answer to that is going to be no, not unless something changes again in the future. So personal dosimeters, of course, we're talking about something like that, as opposed to what I'm going to talk about next, which is area monitoring. Okay, so area monitoring now. So again, controlled areas. IRR 17 regulation 20 says that you don't have a lot of choice. You have to measure radiation levels in and around controlled areas, and you have to keep records of that. So how do we address this? Well, what the previous dental guidance notes suggested was that for workloads less than, say, 100 intraoral or 50 panoramic exposures a week, no further radiation monitoring was required. So in fact, if you were measuring the patient dose once every 3 years, that established how much scattered radiation you were likely to see at the boundaries of your surgery. And based on that, these workloads suggest that there's no question of a controlled area existing beyond the limits of your surgery. Yeah, agency didn't like that too much this time around, and insisted that we have some form of actual measurement method in place. So the options are to place dose meters in agreed positions outside the surgery, or if you have a visiting RPA, they can come and do some dose monitoring for you, perhaps once every 3 years, or calculation of the scattered doses, not strictly a measurement of the radiation levels at the boundary of the controlled area, but it is measurement based. So a calculation of the patient dose of the image receptor position once every 3 years during the equipment testing. Okay, so here's an example of perimeter monitoring around a controlled area. So RPA here, one of my former colleagues, measuring the dose transmitted through a door to check that it's below levels that would require the controlled area to extend outside the door. Okay. And the other option is, as referred to earlier, you can infer what the scattered radiation levels are based on the results of the 3-yearly test. In this case, it's a UK HSA test pack for intraoral evaluation. So that's IRR 17. Those are the main things that came out of that. IRMA, we are looking at a more detailed sort of explanation of responsibilities of IRMA duty holders, that's referrers, practitioners, operators, and how those relate to the professions outlined in the General Dental Council's scope of practice guidance. Okay, so who can do what, diagnostic reference levels, that's measurements of patient dose, how practically to control and limit patient doses, that's optimization of patient dose, and quality assurance, of course, for digital imaging, which replaces the QA program for film-based imaging, and for viewing facilities too. So I'll spend a bit of time talking through that now. So, oh yes, here are the other ones I couldn't fit onto the first slide. So image quality, the old 1, 2, 3 image quality rating system has been replaced by a simpler one, so A or N, acceptable, not acceptable. We've got the syllabus for training of dental care professionals and dentists working with dental cone beam CT equipment, and something to say about the testing intervals for dental X-ray equipment too. Okay, so in the dental guidance notes, there is a very long table of examples of roles that people might have in a dental practice, and what their IRMA sort of title is going to be, and typical duties for those people. Okay, so if you're a dentist who owns a practice and you operate radiography equipment and also interpret the images, you're an employer, you're a referrer. You're almost never not a referrer if you do anything with an X-ray set. You're an IRMA practitioner if you justify the exposures. You're an operator if you operate the equipment, press the exposure button. You're an operator if you assess the, if you report on the images too. That's an operator task under IRMA. Okay, and all the other possible combinations of duties are mapped to their actual IRMA roles in the guidance. That's table 3.2. And for dental cone beam CT in particular, that's quite a nightmarish situation to be faced with for the first time. If you're accepting patients referred to from other practice from outside your practice, there's quite a lot of unraveling of who's responsible for doing what, and that's all set out in the dental guidance notes now. So DRLs, diagnostic reference levels. These are markers of patient dose usually for adults and children for each of the imaging modalities, intraoral, panoramic, cephalometric, and cone beam CT. So here we have an example for panoramic dose area product, and this is actual data. This is the data that went into the current national DRLs for panoramic radiography. So these are markers of how well you're doing in terms of optimizing doses. So these are the doses that are measured every 3 years with the test pack or other radiation safety testing methods. So if the doses you're giving your patients are above these figures, so 81 milligray centimeters squared for adults or 60 for kids, then they're above the national reference levels, and the report from your medical physics expert will say something about efforts that you should take to try and reduce patient doses below those levels. Okay. So the current levels changed a few years before the Dental Guidance Notes second edition came out, and they are as follows. New to national DRLs are cephalometric radiography and dental cone beam CT. So every modality now has its own set of 2 NDRL figures, one for adults, one for children. Okay. Your MPE will take interest in these numbers when they assess your X-ray sets once every 3 years. Practically on a day-to-day basis, though, there's very little that dentists have to worry about with DRLs. They're a requirement of IRMA, but their applicability is much more in the wider medical sense. Okay. There's a lot of guidance in section 4 of the dental guidance notes regarding how to practically go about reducing doses to patients, starting with sensible choices of X-ray equipment. What is a good, what are the desirable features of X-ray equipment? What are the undesirable features? For instance, circular collimation versus rectangular collimation. We don't like circular collimation. The same exposure settings, you're looking at something up to twice the dose to the patient, effective dose to the patient, that is, compared to rectangular collimation. Okay. For the quality assurance of digital imaging facilities, we've now come up with what I think is a measured sort of approach. It's not highly technical. It's not going to take forever to work through it. It's quite simple and straightforward, and as far as possible doesn't involve any computing or mathematics or anything like that. So first of all, there's a visual inspection of the equipment, the sensors, the phosphor plates, the reader, to make sure there's no obvious damage. You take an image of a blank sensor or phosphor plate with a low exposure setting and just look at that to see if there are any artifacts on it which suggest that it's got some damage that might interfere with the quality of the clinical images. And then a further check using something like a step wedge just to see that it's capable of distinguishing different density levels. So yeah, here's what you might get from a phosphor plate exposure. So reasonably uniform. You can see that there are lighter areas around the edge and generally a darkish area in the middle. That's not uncommon. You might also pick out these artifacts here, which are instances of minor damage. So there's a scratch. Oh yeah, here we go. A scratch, first of all, you saw in the first image. There was a bite mark as well. Oh, sorry, I'm getting out of step with my images here. So yeah, small artifacts there. In the next slide, what I wanted to mention was that if there's a phosphor plate reader, if there was a dropped sensor as the phosphor plate was read through, is read via a laser reading system, then missing data would be apparent in this straight line feature here. Okay, so that's a phosphor plate reader fault. And perhaps you might also see small areas of high density, so very, very white spots, which again is missing pixels out of the finished image, which is usually going to be a fault in the phosphor plate itself. Okay. Okay, here we go. Then here's some examples of other artifacts. So here, image A, we've got a scratch of a phosphor plate. These two dots here are a bite mark. Somebody didn't want the phosphor plate being removed from their mouth and started to clamp down on it with their teeth, perhaps. So C, we've actually got a film holder clamp. I don't know why anyone is wanting to stick a phosphor plate in a film holder, but that's where those little white dots came from. And here in D, we can just see the phosphor plate, the actual active phosphor material is peeling off its substrate. Okay, so that's what's going on there. And you might look at these images 1 to 5 and ask yourself which of these is going to be damaged to the extent that you're not going to want to rely on an image produced from that plate to give you a reliable diagnostic information. I would say that 1 is okay and 5 is definitely not okay. I'm a bit dubious about 4, but 2 and 3 might be acceptable. But if you have a new phosphor plate or sensor and you take a baseline image as it comes out of its pack before you use it clinically, you'll have a good baseline image with which to compare to subsequent tests. Okay, the idea is you do that once every 3 months. If you've got lots of plates or lots of sensors, then maybe just do a sample of them once every 3 months rather than having to go through the whole lot. Depends how busy your practice is, how many phosphor plates you're likely to have. But once plates get to the condition of number 5 here, then the QA should pick those up and enable you to make a decision as to whether that should be replaced. Okay, that's the point of all that. It doesn't really matter how well you're quality assuring your digital sensors or phosphor plates if you're looking at them on a rubbish computer screen that's being viewed under incorrect lighting conditions, or just isn't really up to the task, or isn't properly configured to display an image as you would want to actually report on the images. So if you're multi-purposing your screens, using the same screens for using the practice management software and also evaluating images, then you might want to think about that, because the contrast and brightness resolutions are adjustable, and you'd want to adjust your screen for looking at clinical images so as to maximize the various elements shown on this test screen here, to make sure that they are consistent in all 4 corners in terms of how much of the resolution grids you can see, and that this is a smoothly graded light to dark on both sides, for instance. And you can read all the words in these steps at the bottom and distinguish all the squares here and here. Okay, and also measurements of side diagonal dimensions on the screen with a ruler, and side to side and top to bottom. They should all be the same. Okay, so very straightforward test you should do once every 3 months on all the screens used for clinical evaluations. Okay. Now in the guidance, whoops, sorry, it's too early. In the guidance, there's instructions on how to get hold of and how to use this test image. Okay. So you'll all be very familiar with the excellent, acceptable, unacceptable 1, 2, 3 image rating process and the image quality targets. The Dental Guidance Note 2nd edition decided to simplify that because, well, with the advent of digital imaging, there's not so much of a, pardon the pun, a grey area in terms of processing. Digital imaging systems either get it right or don't get it right. They either report an image properly or fail to report an image at all. So most of the issues now with dental radiographic images are to do with patient positioning in relation to the X-ray tube, those sorts of things, as in patient preparation, etc. Yeah, and software is very good at making the very best job out of the image data on the phosphor plate of the sensor and reporting as good an image as possible. So another reason why it might be better to go for a two-step system rather than a 1, 2, 3. So having done that, we decided, well, we couldn't call it 1 or 2 or 1 or 3 because there'd be potential confusion with the old system. So we went for A and N. So images now should be rated either diagnostically acceptable or not acceptable. And it was felt that because of the advantages in terms of less complex processing requirements with digital, but the targets, the percentage of radiographs hitting the acceptable bracket should be higher than for film. So the old 1 and 2 together would have given you this figure, 90%. So there was no increase there, but for digital now, it's 95% of your images should be of acceptable diagnostic quality. No more than 5% of them should be rejects. Okay. And in practice, the great majority of dentists do achieve that. Although I do find as an RPA, there's lots of practitioners who keep very good records for the intraoral radiographs, but don't actually do the same for panoramics or KEFs or cone beam CT. Just to mention that this is an IRMA requirement for all types of clinical image, not just intraorals. Okay, so every image you take should, or every type of image you take should be quality assessed, okay, and audited once every 6 months. Also, it's important to point out that some patient groups are particularly challenging, and I was pleased to be able to include in the guidance this time around advice that if you have many patients who have additional needs, for instance, and can't keep still or require physical support during radiography, then it's completely acceptable to choose, in consultation with your medical physics expert, lower image quality targets. If you can't achieve 95%, go for 75 or whatever is a realistic target given your patient group. Okay, so I guess this is the question: what would you give? What would you rate this image as, A or N? It might depend upon why the image was taken, but looking at all the noise in that image and the peelings of the phosphor, I think I should call that not acceptable. Right. So all I want to say about the testing of X-ray equipment should be done once every three years in almost all cases. Apart from these notable exceptions, any handheld dental X-ray set, because these can be dropped or suffer damage, and because of the potential dose consequences to the operator could be quite significant if that wasn't picked up, they should be tested every year. Okay, it's just a precautionary approach there. Any X-ray set where the patient doses are consistently above the national DRL numbers, despite efforts to reduce those numbers, i.e. there's an equipment issue rather than an operator issue, then that should be tested once every year as well. And again, any X-ray equipment consistently producing poor quality images, suggests there's an issue there. So until that's resolved, X-ray set should be tested annually. Now, dental cone beam CT, we previously said should be tested once every year, but the great majority of them now are provided with suitable quality assurance phantoms that the dental practice can use themselves once a month or so to just check that the equipment is still producing good quality images. If they do, then a 3-yearly test is fine now. So they don't need to be tested annually in the absence of a suitable QA phantom. Even if the manufacturer doesn't provide this, you can buy fairly good ones from a number of sources, and the dental guidance notes give you test criteria you can apply if the manufacturer hasn't come up with a performance specification to compare the results to. In that case, 3 years would be fine for a test interval. Okay, Now, these tests are obviously the radiation safety testing that your RPA or medical physics expert would do for you. Yeah, nearly done. So the last thing I want to mention is just the dental cone beam CT adequate training syllabus, which occupies several pages in Appendix H of the new guidance. So anyone who has anything to do with a dental cone beam CT system has to go through what is now called Level 1 or core training, and that's 12 hours of facts and figures about what cone beam CT equipment is and the radiological precautions you need to be aware of if you're going to be doing anything with it at all. Now, if you're up to date with your CPD in radiology and radiation protection, so you've got your 5 hours under your belt already, then that would then become 7 hours of CBCT focused further training. Okay, but this is intended for dentists, nurses with the certificate of dental radiography, and hygienists and therapists who might also be operators of dental cone beam CT equipment. Anybody essentially. Now, depending upon what the further duties of various people are with respect to cone beam CT, there's level 2 training. So anyone who reports on images is going to have to have proper training in that regard. Anyone who operates the equipment, so nurses, hygienists, therapists, or dentists who take cone beam CT images, they'll need further training too. Okay, if all you do is refer patients to other practices with cone beam CT, you will still need to have some level of appreciation of what an appropriate referral is. So there's a recommendation for referrers for cone beam CT to also undergo level 1 training, and that is actually extending beyond what IRMA requires. But there is a bit of a knowledge gap in cone beam CT in terms of dentists who are freshly graduated. They may not have any training in it whatsoever. So that's why we felt we ought to draw that in. And there we go, folks. An hour and 10 minutes. I hope that was okay. I'm going to sit back and relax a little bit and await any questions, which I'll be very glad to answer.
Fantastic. Thank you so much, Andrew. That was excellent. A few questions have come in here. One here from Polly, right at the very beginning. Can you cover the use of thyroid collars when taking kind of upper standard occlusals, particularly reference to children?
Right. Mm. Okay. If they are or not required.
Yeah, basically,
yeah.
That's the thing.
Oh, crikey. Yes, upper standard occlusal, that will be where the X-ray beam comes down at an angle.
Straight down. Yeah, it's going to go.
Yeah.
Well, it's not okay. Straight down. Yeah.
So the answer to the question is there an opportunity for the thyroid beam to be illuminated by the X-ray beam, thyroid gland, sorry. If the answer to that is yes, then thyroid collars or thyroid shields are indicated. Yeah.
Yeah, it's particularly with the age group as well, isn't it? It is children.
Yes, particularly. So yeah. Now, the thyroid collar that just goes round your neck might not be the ideal one in that case. There are can't think what to describe them as, but they're like annular sort of shields which you can put right on your neck, like a I don't know, a plate with a semicircle missing from the center, so it goes round here, and that might give better protection of the thyroid from the beam coming down from above. But yes, that's covered in the dental guidance notes, and it's going to be section 4 somewhere.
Yeah, there will be a link to the guidance notes with the recording. But it's also, if you go to CG Dent, it's freely available there as well. Okay, so just a question here regarding reporting on X-ray quality. someone was unsure whether you only had to do that when you're doing an audit, basically, not for every X-ray that's taken.
Yeah, there's two approaches which the old guidance notes proposed, and we decided was good to continue with. So you can rate every image as it's taken, and then 6 months later choose a representative sample for the purpose of your audit, or you can at 6 months, at the 6 months point, look back over previous images and extract a representative sample, and then do the rating. Then you don't necessarily have to rate every image and record its A or N as you're going.
Okay.
Although, you know, you'll obviously recognize if you've got a rubbish image and you need to retake it. It'll happen naturally.
Yeah, I must admit personally, I was going to say that you do have to, because I've just got it ingrained in me from hospital work. I always do it, and particularly because it's so simple now with just the two gradings. So the answer is no, you don't have to, but it's
yeah, whichever way works best for your practice, essentially, is the answer. Yeah.
Okay, a question here from Bilal. Hi there. Should a quality assurance audit happen for every type of radiograph?
Yes.
Or could you mix intraorals and DPTs into one audit?
DPTs, would I call those panoramics or OPT?
Yeah. Sorry.
Okay.
Yeah, DPT, OPT, panoramic. Yes.
I would separate them because they're quite different in terms of patient positioning and other factors too. So it's like apples and pears a bit. I would want to keep them separate. Yeah, I would want to keep them separate, to be honest.
Yeah.
And I've actually recommended myself to practices that they do separate image quality audits.
Yeah.
Each modality.
I mean, it's a question we're often asked when we run audit courses. And would you ever recommend, or do you have a sort of set of audits that you would recommend people do within the guidance? Is there anything like that?
Image quality wise,
yeah.
I'm not quite sure how you.
I'm just wondering whether there's almost just like a recommended, or we would recommend you would audit to this and all that and particular timescales. Not particularly, no.
No. Do you mean clinical audits?
Yeah.
Looking at the right. Okay. I don't know, but I think one of the appendices might have a pro forma audit plan.
Yeah.
So, which will contain everything. Yeah.
That's great. Okay, and just a comment here with regard to the check you did with the intraoral machine. Somebody was concerned it had no collimator, but I think it was just a round collimator, wasn't it, rather than a rectangular one?
Oh, was that one of my images showing a test pack?
It was, yes, it was a test one. So that was,
yes.
Going back to slide 25.
Right. Yeah.
I think that's...
Yes, apologies for not thinking about what I was choosing to show to people. Actually, that
hang on,
that does have a rectangular collimator attachment on the end. I can just see it poking out. So
there you go.
Yeah, there you go. Yes.
Mark answered. It was there.
It was there. Yes.
It was there. Yes. Well spotted, though. Okay. Okay. So a question here from Polly. It's a clinical question, to be fair. So I'm not sure you'll be able to answer this question. Our small bite ring radiographs are too large for some of our very small patients that are 4 or 5 years old. If we used old ones and cut them in half, that's presumably where, but if you cut a digital plate in half, would that cause a problem?
I think phosphor plates, you can do that to them and they would still work.
Yeah.
Yes.
it might be worth trying it on one of your old ones just to check it first of all, make sure it still works.
Yeah, and if you've got a step wedge or something similar you would use for your digital QA, just do a test exposure using that first, or some other object with
of course you'd
yeah,
reduce the exposure, wouldn't you, because of that. So yeah, that's so Polly, not a daft question, actually quite potentially a good idea, but you just check it, obviously. Okay.
Yeah.
That's great. Okay, I think we're through the questions. Okay, thank you so much. As the reason for doing this is really just to we all of us know the new guidance has come out, but very few of us actually make time or seem to have time to read it. So we thought it'd be really useful to have one of the authors to actually go through the key changes in the guidance. So it's kind of bringing the guidance to life, really. So that's fantastic. I think you've done that job wonderfully. Thank you so much, Andrew. I think we'll
a pleasure. Thank you.
Stay there. So yeah, hour and 15. Oh, one more question. So, oh, here you go, Connor. Sorry, get your questions in now before we leave. Oh, here we go. It's regarding. Can you see the question actually from Connor? It's would I be correct in stating that if the whole of the surgery floor space is classified as the controlled zone, and the operator is taking the X-rays within that zone, even at a distance of 2 meters from the main beam, the operator should carry out monitoring, be monitored as well?
With a personal dose meter, yes.
Yeah.
So even if they stand outside the room to take the exposure, the controlled area will still be deemed to exist just, well, from some time before the exposure takes place to some time after. When if it's intraoral, when the X-ray is switched on, the controlled area is considered to exist all that time, not just during the X-ray exposure. And because of that, the regulations say monitoring is required, even if they're not going to be inside the room at the time the exposure takes place.
Okay, that's great. So never apologize, Connor, for asking questions. That's how we learn. Okay, thank you. I feel like the auctioneer at the end. Oh, one more. Go on. Okay. No problem, Connor. Okay, so it's a question from Polly, really, regarding cutting the films in half. They've done it successfully, but they're a little bit worried about would there be any problems with chemicals leaching or damage, or?
I don't think so. No. I'll probably want to ask the phosphor plate supplier to answer that question, but I can't imagine that there would be any adverse consequences to the patient. I mean, phosphor plates degrade over time in any case, so
yeah. They're also within a sort of a sleeve anyway, aren't we?
Well, yes, that's right. Yes.
Yeah. Okay.
So I
suspect if you ask the suppliers, they will happily supply you a smaller phosphor plate at huge cost.
Oh, yeah.
That may not be the best.
Yeah.
Okay, that's fine. According to the new regulations regarding a controlled area, do we have to turn off the X-ray machine every time we enter the room to take a new X-ray, the same patient?
No.
If I'm thinking it right here, it's a patient you're taking perhaps a pair of bite wings or 2 or 3 PAs. You don't need to. Do you need to turn off the machine between every exposure?
No, not at all. No. But you just need to be aware that if the X-ray machine is turned on, the potential for an exposure exists, even though it's perhaps a remote possibility. But
yeah,
because of that, it has to be considered a controlled area.
Yeah, you just need to make sure whoever's got the controller doesn't press the button.
Yeah, what we should really do is switch off the X-ray set when it's not in use.
Yeah,
so for intraorals, it's a bit harder to do that for some of the extraoral equipment, but then they generally have means of making the disabling the exposure button.
Yeah, I think it's more to do with if you be going back into the room to take multiple small radiographs, and I can understand exactly what you're saying, I think, but I think you just need to ensure that whoever has the controller does not press it. So, because again, it's a risk, isn't it? There is a minimal risk there.
Yeah, yeah.
Okay. I'm not sure what you're meaning there, Mark. Cross-infection outshield broken. If there's anything, if you want to add anything else there, I'm on cutting plates. Oh, cross-infection. Oh, I see. So if you cut the plate, could it be a cross-infection issue? I'm not
That's
sure.
outside my
yes, outside your field of expertise and mine. We can ask the question for you, Mike. I know what you're saying there. I suspect because the plates are within the packet, then it would be okay, but it may be worth asking one of our infection control experts. I will ask for you. We're running a webinar in a couple of weeks' time actually on sustainability, but it's actually been run in collaboration with CD Dent again, but also the Central Sterising Club, who are an independent body of infection control experts, and I'm sure that they will have an answer with regard to that, because they're not just dentally based, but they're also hospital based as well. So I'll ask the question for you, Mark, and get back to you. Okay, thanks. That's brilliant. Any more questions? Otherwise, we're going to let our line go. Okay, Andrew, thank you so much. Brilliant presentation, lots of great questions. It's always a challenge to make it interactive in this sort of environment, but I thought you did a brilliant job. So once again, thank you everybody for giving up your time tonight. So, okay, once again, thank you so much. Good night, everybody. Stay safe with all the wind, and we will see you all not next week, but the week after. Okay, take care, and thank you again once again so much.